You know when you're using tools like Figma or Canva, and as soon as you move or rotate a shape, those little dotted guidelines appear and everything just snaps perfectly into place? Yeah, that feature is honestly so satisfying and super useful. It makes aligning shapes so much easier, so I thought, why not try to build something like that myself? And that's what this video is about. I tried creating a simple smart guide system, just like in Figma, using Pixi.js, and it's not perfect yet, but for a basic version, it actually works really well. Let me show you how I built it. So I hope you already know how to install Pixi.js. If not, just go through the docs. It's super simple. I already have the project set up, so without wasting much time, let's jump straight into the code. Now in the main.ts file, I'll just give you a quick walkthrough because most of the setup part is pretty straightforward. So here, we're just creating two rectangles, one red and one green, and then we make them draggable using a function called makeDraggable. Alright, let's break it down. So first, we create a Pixi application, set the background to a dark color, and then attach the canvas to our HTML container. Next, we create a separate layer called Guides. This layer will handle all those dotted alignment lines when we move the shapes around. Then we draw two rectangles, set their positions, and add them to the stage. After that, we call makeDraggable for both shapes, one for the red rectangle and one for the green rectangle. And we pass the other shape along so that when one moves, it can check alignment against the other. Now, let's look inside the makeDraggable function. So this function basically takes three things: the shape we want to drag, a list of other shapes we want to compare alignment with, and the guide layer where we'll draw our dotted lines. We set the shape's event mode to static so that it can receive pointer events, and we set the cursor to pointer to show it's draggable. Then we define a few variables: dragging, offset x, and offset y. These help us track when the user starts dragging and how far the mouse is from the shape's top left corner. When the user presses down on the shape, pointer down, we set dragging to true and store that offset between the mouse position and the shape's position. This makes the dragging feel smooth and natural. When the user releases the mouse pointer up or pointer up outside, we stop dragging and clear the guidelines because we don't need them anymore. And finally, in the pointer move event, this is where the main action happens. If we're dragging, we update the shape's X and Y position based on the current mouse location minus that offset. Then we clear the guide layer and check for alignment with all the other shapes by calling our drawGuides function. That's what shows those dotted snapping lines: top, bottom, center, left, right, everything. So basically, makeDraggable handles both the movement and the live alignment checking at the same time.
Alright, so now we want to add a button that lets us create new shapes, or in our case, yellow squares, every time we click on it. The idea here is to make our canvas interactive, so instead of starting with only a few shapes, we can keep adding more as we go. First, I grab the button element from the HTML using its ID, add square. Then I create an empty array called objects. This array will act as a container to keep track of all the shapes that we've added on the screen. Think of it like a list that remembers every square we've placed so far. Next, I add an event listener to that button. So now, whenever the button is clicked, this piece of code will run. Inside that listener, I start by creating a new square using the Pixi graphics class. To make sure each new square doesn't overlap in the exact same place, I randomly position it somewhere inside the canvas, subtracting a bit from the width and height so it stays fully visible. Once the square is ready, I add it to the stage, and then I push it into our objects array so we can keep track of it. Now here comes the smart part. We want every new square to be draggable and to show guidelines when it aligns with other shapes. So, right after adding it, I call our makeDraggable function and pass in two things: the square we just created, and all the other objects that already exist on the screen. That way, this new shape knows about the rest, and it can snap or show guides when it lines up with them. But that's not all. The older shapes also need to know about this new one. Otherwise, the guides would only work one way. So what I do is loop through all the existing objects again, and for each one, I call makeDraggable the same way. This time passing in all the other objects except itself. This step ensures every single shape in the scene is aware of every other shape, so they all interact correctly when you drag them around. Basically, with this setup, every time you click the button, you're adding a brand new draggable square that automatically connects to the rest, and all the older ones get updated to recognize it too.
Okay, so now let's look into the guide.ts file. This is where we actually draw those dotted or dashed alignment lines. Now the first two functions here are just helper functions that we'll use later, so let's go through them quickly. The first one is the getEdges function. This one's simple. We take a shape, which in our case is going to be a rectangle, and we calculate all its key positions. So we return the left, right, top, and bottom edges, and also the center X and center Y. Basically, all the points we'll need later for checking alignment with other shapes. So for example, if you move one rectangle near another, we can easily compare their edges or centers to see if they line up. Now the second function, draw dashed line, is a bit more interesting here. We're drawing a dashed line between 2 points x1, y1 and x2, y2. It also takes two extra parameters, dash and gap, which define how long each dash segment is and how much space we leave between them. Inside the function, we first calculate the distance between the 2 points using the Pythagorean formula. Then we figure out how many dashes can fit into that distance based on the dash and gap size. We also calculate the angle of the line using math.atan2. That gives us the direction of the line in radians. And if you want to dive deeper into how this atan2 function works and how it calculates the angle, I highly recommend watching this video. But for now, let me give you a quick overview. So atan2 is basically an improved version of math.atan. The normal atan function only gives you the angle between minus pi over 2 and pi over 2, which means it can't tell which quadrant your point is in. It only looks at the ratio. That's where atan2 comes in. atan2 uses both x and y values together to figure out the actual direction of the line, so it gives you the correct angle for all four quadrants. The range of the angle it returns is from negative pi to positive pi, or negative 180 degrees to positive 180 degrees. So, in the first and second quadrants, where y is positive, it returns a positive angle. In the third and fourth quadrants, where y is negative, it returns a negative angle. This makes it perfect for graphics and rotation because it always tells you the correct direction of the line, whether it's going up, down, left, or right. So in our case, math.atan2 gives us the exact angle between our 2 points, and then we use that to move along the line correctly when drawing the dashed segments. Now here comes the trigonometry part. You'll see math.cosangle and math.sinangle. These tell us how much we need to move in the x and y direction for each small step along the line. Think of it like this. If the line is perfectly horizontal, cosine will move us along x, and sine will barely move us along y. But if the line is at a diagonal, both cos and sin will move us proportionally in x and y so that the dashes follow the correct angle. So every time we draw a dash, we multiply the cos and sin values by the step distance. That's how we know exactly where the next dash starts and ends. Then, inside the loop, we keep moving forward and drawing these short line segments with small gaps in between, and that's what gives us that nice dashed effect. And that's it. Pretty clean, simple, and very reusable. We'll use this later to draw the guidelines between shapes when they align perfectly. Alright, so this is our main function, the one that actually handles all the smart guides and snapping. We call it like this: Draw Guides app, shape, other, guide layer. Here, A is the shape we're dragging, B is the other rectangle we want to align with, and G is just the guide layer where we draw those dotted lines. Before we go deeper, a quick note: this system only works correctly if your shapes are not rotated, because our getEdges function assumes that shape.x and shape.y are the top left corner and that width and height are straight. No rotation or anchors involved. If you rotate the shape, the math won't match what's actually on the screen. Okay, now back to the code. We start by calling getEdges on both shapes to get all their sides and centers: left, right, top, bottom, center X, and center Y. We'll use these values to compare and detect alignment. Next, we define a few constants. Tolerance means how close two edges need to be before we consider them aligned. Dash and gap are just for styling our dotted guidelines. We also set the line style, a thin white line with a bit of transparency. This keeps our guides visible but not too strong. Then we create two variables, snap_dx and snap_dy. These are going to store how much we should nudge our shape in x and y to make it snap exactly to the nearest alignment. Now let's look at the vertical alignments. That's everything along the x direction. We build a list of all the possible edge pairs we can compare between shape A and shape B. For example, left to left means both shapes' left sides align. Right to right means both right sides align. Left to right checks if the left edge of A aligns with the right edge of B, and so on. We even have cross alignments like center left or right center, which allow the middle of one shape to snap with the side of another. That's how you get more flexible snapping, not just edge to edge. Then, for each of these pairs, we calculate the difference between their x positions. Basically, how far apart they are. If that distance is less than our tolerance, we draw a vertical guideline at that x position. We use the draw dash line function for that. It draws a dotted line across the whole screen height. At the same time, we record the snap distance, and if it's the closest alignment we've found so far, we save that as our new snap_dx. We repeat the exact same process for horizontal alignments, just in the y direction this time. So we compare top to top, bottom to bottom, top to bottom, and even center to center alignments. Again, if two sides are close enough, we draw a horizontal dashed line across the screen, and we track the smallest offset for snapping vertically. Finally, after we've gone through all the comparisons, we apply the snapping by adding snap_dx and snap_dy to our shape's position. This makes the movement feel precise and responsive. It sticks exactly where the guide shows. So yeah, this function does all the heavy lifting. It calculates all the possible alignments, draws the visual guides, and makes your shapes snap beautifully in real time. Alright, I know this is a pretty simple algorithm, but I'm sure some of you already have your own ideas or different ways to achieve the same effect. If you do, let me know in the comments. I'd really love to see how you'd approach it. And because this snapping system is such a useful feature, I just wanted to make a simple demo version to show how it works. I hope you found this video helpful, and if you did, don't forget to like, share, and follow for more. Right now, I'm mostly making videos on topics I'm personally exploring and learning myself. So if you've got something interesting or unique you'd like me to cover next, just drop it in the comments. I'll try my best to make it happen. Thanks for watching, and I'll see you in the next one.